Alright folks, hello and welcome to this video example. In this video we're going to be looking at number 2 of the take-home quiz, and I'm going to be walking you through an example of how to write a quadratic function in standard form and change it into vertex form. Here is my quadratic function that I chose. You cannot use these numbers. Okay, so when you make your quadratic function, make sure at least 2 of the numbers are different because you have to make up your own. I even give you a hint of how to make it a little bit easier, but these numbers will do for our purposes. So in order to change it into vertex form, we're going to use the method of completing the square. There are other ways to do this, and you're welcome to look into those if you want to research on your own. We're going to use completing the square as a way of changing this into vertex form. Sorry about that, a little messy there. There we go, completing the square. First thing I want you to do is let's drop the y for a moment and just set it equal to 0. Previously, when we completed the square, we always had one variable x, and I want to use that same idea. Later on, we'll put back the y where the 0 is, and then we'll have our quadratic function. And then we're just going to follow the steps of completing the square. First, we want to isolate the constant. So I'm going to subtract 10 from both sides, and we get negative 10 equals 3x squared minus 9x. Isolate the constant. Now, our rules, when we wrote them down, were isolate the constant on the right-hand side. So let's switch this equation around and put the negative 10 on the right-hand side. I left a space there, but we don't need to fill that yet, because next we need to make sure we have a coefficient of 1. So since there's a 3 there, we're going to factor out a 3, and then we get x squared minus 3x equals negative 10. Again, strategically pick your numbers. Notice how it was nice and easy for me to factor out a 3 from both of those terms. That might influence your choices for your first 2 coefficients. Moving on. Next, it's time to add the blanks. In order to complete the square, we want to add something that makes this polynomial factorable and a perfect square. Plus blank equals negative 10. Whatever you add to one side, you add to the other, plus blank. In this blank, we use the rule of doing b over 2 squared, or the middle term divided by 2 squared. In this case, it is negative 3 divided by 2 squared, which will actually give us 9/4. So in the blank, using that rule we just did, negative 3 over 2 squared, we know that there has to be a 9/4 in this blank, which means there will be a 9/4 in this blank. If you don't like the fractions, you can use the calculator to help you out. The next step is to factor the polynomial. The quickest way to do this is to remember the rule that this will always factor into a perfect square, or it's a perfect square trinomial, which will always factor into x minus or x plus a number. What is that number? Well, it's always going to be that b over 2 term that we saw above. We did b over 2 squared, but that b over 2 will always end up being that number in parentheses. So in this case, it is 3 over 2. In fact, it is negative 3 over 2, so that's why we have our minus sign there. And then we square it since we factored it. And then on the right side, we write equals negative 10 plus 9/4. You can do some quick math there, or use the calculator to help you. That is negative 31 over 4. Now, normally we would try to isolate x and solve by square roots, but take a look at how close this looks to vertex form. Recall that regular vertex form is this, where h comma k is the vertex. So we're very close to looking like vertex form. We have parentheses, we have a number in front, we have a number on the right. All we want to do is bring this number back over on the same side as our x variable. So I'm going to add 31/4 to both sides. And if you don't like 31/4, you can make it a decimal. There's no problem with that. And our final result will be 3 parentheses, x minus 3 over 2 squared, plus 31 over 4 equals 0. And then just remember what we did at the beginning. We exchanged the 0 or y for a 0. So at the very end, we'll put our y back where the 0 is. This will become our y. In other words, we'll be allowed to write our final quadratic function, which is y equals, and then all this stuff. That will be the vertex form. 3 times, let's convert it to a decimal now, because it's a little easier to plot that on a graph. 1.5 squared plus 7.75. And that is an example of how to turn your own standard form equation into vertex form. I highly suggest you choose easier numbers strategically so that you don't end up with as many fractions as I did. But if you did end up with fractions, you can use the calculator or your own arithmetic to help you out, and feel free to return to this video for more help. Thanks for watching this video example.